I think, a little bit more straightforward. So this is on me just because I didn't know how they wanted us to ask this question. So what the Heparin protocol is just basically, it's this multi-step thing that would be like in your chart or on a poster or on the wall or somewhere where you could see to follow the steps. The majority of the protocol is not math based, it's just procedure based, right? So steps 3 through 9, you can see where I put this big giant red X through here. That just tells you that you can ignore those steps. That's not, you're not being asked to fill that in. What you're being asked is to answer the questions after the protocol. Okay. So, and you're going to be answering 2 questions per Heparin protocol. The first question is calculate a bolus dose strength in milliliters, or calculate a bolus dose in milliliters. And the second question is calculate a the flow rate or the drip rate for the heparin IV. On the practice, I gave you 4 questions. I gave you the initial, asking the initial bolus, initial infusion rate, and then after assessing the patient and finding out the APTT, then to calculate a new bolus and a new infusion rate. And so I'm going to go through all that here right now. So the first thing you see, the way this question is written, is it'll say, the protocol is, or the order is, to bolus the patient with 80 units per kilogram body weight, and then to start a drip at 18 units per kilogram per hour. Now, this starting a drip, that's the thing that's a little bit like kind of a misnomer, because you are probably used to seeing not drip, but just flow rate. And then you might be thinking, oh, drip, drop rate, but that's not what they're asking you for. And I'll explain why that is in just a moment. They'll also give you the patient's weight in pounds. So the first thing you need to remember to do is anytime you see a patient weight in pounds, you need to convert those pounds to kilograms. If you're at some of the other campuses, they don't like you to do what I'm about to show you. But I'm going to tell you, if you divide by 2.2, and you're going to get 50 kilograms, it's a whole number. So you don't need to worry about decimals and all that kind of stuff. But if you are concerned about that, you might want to set these problems up just a little bit differently. But if you go onto my YouTube channel, I've actually worked through a couple of these where I factored in the patient's weight without rounding until the very end. So there are practice problems if that applies to you. If you're at Allegheny campus, converting pounds to kilograms, rounding to nearest tenth is sufficient for answering the questions. All right. Sorry, that's bothering me, like how that looks. Let me just fix that. So I'm just going to say it equals 50 kilograms. All right. So when we look at the protocol, there's a couple of steps that are important. We need to know what we have available. So we know that it's 80 units per kilogram body weight. We also know that it's 18 units per kilogram per hour. That is actually restated in the as the order down here, or the protocol: bolus with 80 units per kilogram, and then start a drip at 18 units per kilogram per hour. So it's repeated. Okay. The available is what's listed here in step 2 of the protocol. We have available heparin 25,000 units in 250 milliliter half normal saline. And then we have a bolus dose strength of 1,000 units per milliliter. So we have 2 things. We have a bolus and we have an IV. Okay. So we have 2 available. So that's the other thing that's a little bit tricky about this problem set, or this problem in general, is because there's extra information, but it's just a matter of putting it kind of together. So, which we're going to do. And then we'll come back to steps 11 through 15. We don't need that for the first, to solve the first 2 things. So to answer the initial question, you're going to take the patient's weight, and you're going to multiply it by the order, which is the 80 units per kilogram. Okay. That's going to give you 4,000 units. Now, if all they wanted was units, we'd be done. Unfortunately, they want more than that. So we're going to take our 4,000 units and we need to convert that to milliliters. Our conversion comes from our available. So we're calculating a bolus. So the bolus dosage strength is the 1,000 units per milliliter. So I'm going to come back down here. 1,000 units per milliliter. I'm going to put that in my calculator. I'm going to get 4 milliliters. That's supposed to be units, not unals. Okay, units. So that's how you would calculate for the bolus. The only thing that would change on this problem is the patient's weight. So if the patient weighs 75 kilograms, if they weigh 80 kilograms, if they're 45 kilograms, we would just still solve it the same way to get to whatever our milliliters are. If for some reason you got to a point where it was a decimal answer, 4.5 milliliters, that's your answer. Okay. For the flow rate, the infusion rate, so it tells you to look for milliliters per hour, even though it's calling it a drip. And it is going pretty slow because it's going to be like, 10 milliliters an hour or something like that. It's really, really slow. So 50 kilograms. What was our initial infusion rate? Well, it told us 18 units per kilogram per hour. That'll give us 900 units per hour. We don't want units per hour, though. We're looking for milliliters per hour. So you already did some of these problems, right? So like 22 and 23 were converting units per hour to milliliters per hour. So I always say those are kind of like workup questions in this practice set to prepare you for these here. So we're going to convert units per hour to milliliters per hour. But in order to do that, we need to eliminate units and convert to milliliters. So we're going to go back to our protocol and we're going to look at our available. And you can see our available is 25,000 units in 250 milliliters, half normal saline. So that's what we're going to use as our available for our flow rate calculation. 250 milliliters, 25,000 units. I'm going to do that math and I'm going to get an answer of 9 milliliters per hour. So again, the only thing that we're really going to be able to change for this heparin protocol is the patient's weight. So if the patient is 70 kilograms, 50 kilograms, 45 kilograms, 85 kilograms, whatever their body weight is in kilograms, that would determine what our milliliters per hour is, and then what our bolus dosage strength is. Okay, so that's what you would see. So these two things that are listed here, you might see that at Allegheny campus, you'll see that as that'll be one question. So you need to answer in one question the bolus and the flow rate. It'll count as one question. So if you miss them both, you've only missed one question. And if you miss one, you missed one question. Okay, so you got to get them both right to get the question correct. But I think if you practice this enough times, you won't have a problem with these questions. The next variation is basically the same thing. It's just that we're going to follow slightly different directions. So it says after 6 hours, we take a APTT, and so we're reassessing the patient, and it's 43 seconds. We're going to look in our table here, and we have some different APTT times, right? And so we look for the one that fits what we're looking for. So 43 seconds goes in between 36 and 44. So we're going to follow the steps listed for that particular APTT. And what are the steps? Rebolus, so do bolus again with 40 units per kilogram, and then increase the original rate by another 2 units per kilogram per hour. If our original was 18 units per kilogram per hour, we're going to raise it up to 20. So let's go ahead and do that. So patient's weight, again, same patient, 50 kilograms. And I'm going to multiply by the bolus dosage strength, which is the 40 units per kilogram. That's going to give me 2,000 units. Now, I know, I imagine if like you're watching this on the replay or if you're at another campus and you prefer to just do the long dimensional analysis, that's perfectly fine. We're going to come up with the same answer. I chopped this up just so you can kind of see where we're going. And also, like in the question above, the 900 units per hour, that's going to look very similar to previous questions you've done. And my hope is that it gives you a little bit more confidence, like, oh yeah, I've seen this before. I know where we're going here. Okay. So that's kind of why I do this. But if you're doing it all as one long dimensional analysis, and you're coming up with the same answers I'm coming up with, we're doing the same thing. I'm just chopping it up. Okay. All right. 2,000 units. Remember, this is our bolus. So remember what our bolus dose strength is. It was 1 milliliter, 1,000 units. So my answer would be 2 milliliters per hour. Now, you could have saved yourself a step, because if you knew that the original was 4 milliliters per hour, and then we cut it in half, right? Went from 80 units to 40 units, then we would know, okay, it's 2 milliliters per hour, it's half. But it's good to work through it as practice. Also, your test may just say, here's the protocol, or they give you the details, the available and everything like that. And then they're going to say, after 6 hours, APTT is 43 seconds, prepare a bolus, and you may not even know what the original bolus was. Okay. All right. Last is the calculating the infusion rate. Again, same patient, same weight, 50 kilograms. Now, remember, it said to increase the infusion by 2 units per kilogram per hour. So that's where I'm writing down now, the 20 units is coming from. That'll give me 1,000 units per hour. Once I have that 1,000 units per hour, we can convert units per hour to milliliters per hour by eliminating units. And we do that by, again, looking at our available. It's the same IV that the patient is still on. That same IV that contains 25,000 units of heparin and 250 milliliters half normal saline. And we're going to get an answer or a flow rate of 10 milliliters per hour.
See, I did that one a little differently.
Okay. Did you get the same answers?
I got the same answers, but I did the 25,000 over 250 milliliters multiplied by 1,000 units per milliliter over X, and then I got the 10 ml.
So you solved for X?
Yeah.
That's fine. Yeah. You're using algebra. I don't assume that everyone in a nursing program is good at like kind of, doing like algebraic expressions, but that's fine. You did it right.
Okay.
And then now you are hopefully seeing an alternative way of doing it. So, but yeah, that's perfectly fine. As long as you got the same answer, you're good.
Okay.
Now, just to kind of frustrate you a little bit, I'll show you what this looks like on the what's it called? What they would see for Boyce. The way that theirs is written is just a little bit different. So like when their heparin protocol, it's going to look more like this. So notice that everything's kind of exactly the same. But basically they deleted out all the extra stuff. So this I think looks a little bit cleaner, but it's basically the same. And actually this is the exact same question that I just went over. But what I wrote out actually is I did a different variable. I did 175 pounds instead of 110 pounds just to kind of show. And then I also did it the long dimensional analysis way, again, just to kind of create some variation so you can see what this would look like if you did it that way. If you start with milliliters first, or milliliters per hour first, then that's perfectly fine. You would just do the reverse order of what I did. You would just write, this would be step 1, step 2, step 3, step 4. I do it backwards maybe than what you have seen it, but it comes out to the same answer. There's not one right way to do these. It's just how you organize it. So my preference is organizing it this way. You may prefer to organize it a different way. As long as you're getting the right answer, you're doing it right. So this would be one question that you might see on like a Boyce type test, where you have like a weight-based protocol, heparin protocol. You answer both these questions, the bolus and the infusion. Okay. Allegheny campus, similar. It's just that the question was going to unfortunately will have all the rest of the protocol in it, but it's basically the same thing. Then when you come down here, you can see that there's other versions. Okay. So this is showing you a different protocol with a 500 milliliter infusion, or 500 milliliter IV instead of the 250 milliliter IV. So you just use whatever values they give you and just follow the protocol the same way. For this one here, so they gave you an APTT of 55, and then they told you within the context of the question what to do with that. So you're increasing by 2 units per kilogram per hour, currently receiving 18, right? So we talked about this. So 18 increased by 2, so this would be 20. What is the new rate of infusion? And then it says use the same initial weight to calculate the new rate. So the initial weight is going to be the 75 kilograms. So these are just kind of same questions, just pieced together differently. I do believe that at Boyce, you're going to have some weight-based calculations that might be worth looking at. So let me see what we got here. What I mean by that is these types of questions here. I can't remember if that's in your blueprint. I know it's in the 240 blueprint. I just don't remember if it's in your blueprint. But basically, it's just a matter of converting, going from micrograms per minute or milligrams per minute to milliliters per hour. I do think that this is more a 4th semester type question, but you can tell me if otherwise. Oh, and if you came in after I asked, if you don't mind, please put your name and campus in the chat. I think one other person joined.
I'm here for heparin, so I'm good.
Okay.
I believe I started it off with MLs.
Okay. Now, the reason I ask that is because I want to be consistent and try and do it that way. It's the same way that likely you would have done it. So if I'm starting with mLs and we're doing that because we know we're looking for milliliters per hour, I'm going to take my 250 mLs over the 50 milligrams. My next conversion factor is going to be incorporating the micrograms per minute. Okay, so you can do this a couple of different ways. The first thing you need to just be clued in on is that we have micrograms and we have milligrams. So I need to convert one, either micrograms to milligrams, or I need to convert milligrams to micrograms. Since we already have milligrams listed here, let's just go ahead and convert milligrams to micrograms. And we'll do that this way. Now, and then now we've eliminated milligrams. Now we can add in our micrograms. So we'll start off with the first microgram, 15 micrograms per minute. So far, so good. We're in milliliters and we're in minutes, but we don't want minutes, right? So we're going to convert minutes to hours. And so that's how you should have, or that's how I would set that up. Starting, if I were starting with milliliters, then just plug it into my calculator, 250 times 15 times 60 divided by 50 divided by 1,000. And then I'll get the same answer I had previously written, the 4.5 milliliters per hour. Is that how you set yours up?
Yeah, I usually write out everything to the dimensional analysis way.
Perfect. I honestly, what one of the like kind of benefits of doing that, especially if if you end up missing a question or something like that on one of these drug math tests, it's helpful for somebody who's looking over with you to be like, oh, okay, this is where you miss. Like in the 130 class, I was talking with somebody and they forgot to convert milligrams to micrograms. And so they immediately, like they missed or they skipped this part of the dimensional analysis. And because of that, they weren't getting the same answer I was getting or what the key said. And so, but once we worked through it, then we saw what that was supposed to be. You would set up the second part of this the same way, except instead of 15, you would use the 200 and everything else would be exactly the same. That's what these dotted lines are, is just to say, like, to quote what's above. So I would just do 250 times 200 times 60 divided by 50 divided by 1,000. And then I would get the 60 ml per hour. Good question. And thank you for answering my question. So any other questions?